Hello everyone. Thank you for watching this session titled Access Analysis of Data Platform Users. I am Takahiro Moteki from the Data Infrastructure team in the Data Platform Department. First, I'll give you a brief introduction of the Data Platform Department and then move on to the Access Analysis of Data Platform Users, then lastly talk about the design and implementation. First, let me introduce the Data Platform Department. Our mission is to provide the data platform as a service to line employees around the world. What do we do specifically? We are providing data infrastructure and developing BI tool for employees' use. You can think of them as an internal infrastructure for internal products. Specifically, we develop Hadoop clusters like clusters and storage, intermediate data for queries and analysis, pipeline for data ingestion, self-service tools, and web systems. In other words, we provide the overall products and infrastructure that employees need for data-related work. This slide shows you the resource scale. This includes Hadoop and other tools. For example, we have over 300,000 workloads per day and more than 56,000 tables. As you can see, this is a significantly large platform. Next, I will focus on Hadoop within the platform and talk about the access analysis of line global employees, our platform users. As KPIs for the access analysis, we have 6 types of index to aggregate. From the top left, let me go through them in order. DAU stands for Daily Active Users, which indicates the unique user scale by day. MAU stands for Monthly Active Users, which indicates the unique user scale by month. DAC stands for Daily Active User Count, which indicates the daily usage by users. In other words, you can tell how many users use the service on a daily basis. MAC stands for Monthly Active User Count, which is DAC by month. RR stands for Retention Rate and tells you the user stickiness rate on a particular period. This helps us understand how consistently users use the service within a certain time frame. DR stands for Dormant Rate, an antonym of RR, showing the number of users that are not using the product on a particular period. This helps us understand how many users went dormant or stopped using the service during the period. From the next slide, I'll show you some of the actual indexes, although I cannot cover all of them due to the time constraint. First, here's DAU. On the left, you see the DAU of a yarn cluster at a particular point of time. Currently, the value is higher than 500. On the right hand, it shows the DAUs of the 3 Presto clusters at a particular point of time. To optimize Presto clusters by usage, we have 3 clusters. This could go as high as 200, and in total, it's about 300. The DAUs only show the users who directly use data, and users accessing data indirectly, for example, from dashboard of BI tools are not included. And of course, if we add them, it's going to be higher. And this is DAC. On the left, you see the DAC of a yarn cluster at a particular point of time. The analysis axis of DAC is the number of yarn application submission, and it's limited to the successful applications. This graph tells you that at its peak, approximately 70,000 yarn applications are submitted on one day. On the right side, you see the DAC of 3 Presto clusters at a particular point of time. As mentioned earlier, Presto clusters are optimized by usage, so we have 3 clusters. The analysis axis of DAC is the number of issued queries, limited to successful queries. So far, I've covered DAU and DAC, and as you can see, line employees actively access these tools from various countries every day for data analysis. Now, I am going to introduce you to one case example of how we utilize these values. This is an example of internal infrastructure project for online cluster migration. This was an online migration project to migrate Hadoop cluster A and B to Hadoop cluster C. In the pie chart on the top right, we conceptualized the goal of this project by combining the different DAUs and creating a new KGI, which we tracked as a whole project. The created KGI index was MR, which stands for migration rate, indicating users' migration rate on a particular period. The bar graph on the left side only cites the MR of the Hadoop cluster C. What we gained from MR initially as an insight was that the rise of the KGI MR was gradual, suggesting that the user flow for migration was not sufficient. In response to that, we had held workshops for users and obtained insight on how we can improve the migration process. So why do we care so much? Users, the line employees, are accessing our service from all around the world, and its scale is pretty large. We care because we want to promote migration while still adjusting for users' schedules and to reduce communication costs to reach out the users. So far, I've introduced KPIs like DAU. These can be also drilled down into detailed segments for reference. This slide shows a segment tree defining analysis axis. Specifically, DAU can be referred to by account type like personal account and system account, or by component such as Hive and Yarn. If it's Hive, then you can even refer to it by user action for read or select query, write or insert query, and DDL query. Next, I'll talk about the design and implementation. So which logs did we use? Well, we manage very diverse ecosystems, and there are many clusters as well. Among these ecosystems and clusters, we need to obtain logs from everywhere. To that end, we use Ranger audit logs. However, there's actually an ongoing unresolved issue that Presto cannot be managed by Ranger, so we developed a plugin to collect query logs. So we have a separate way to get query logs for Presto. Next is implementation. We collect Ranger audit logs and Presto query logs and store them in HDFS. The stored logs are aggregated on Airflow by using Hive, and we create intermediate data on a daily basis. From BI tools, we use Presto for daily visualization and analysis of the intermediate data. Lastly, let me touch upon our future prospects. First, by extending this implementation, we are aiming to establish a system that we can convert each user's resource consumption into cost and generate reports. Second, we are trying to add more KPIs and segments. And finally, we consider analyzing the daily aggregation on an almost real-time basis so that we can detect unintended usage. This concludes my presentation. Thank you so much for your attention.